Hi, so in my last video I went over the vertical asymptotes of defining limit approaching, we did infinite limits. So now we will be doing limit as x approaches infinity. So for this, if you see that it's a polynomial and it's approaching infinity, then you'll have to find the horizontal asymptote. So basically for this, you can see that these two are the same power. So then all you have to do is take the ratio. So it's just 3 over 1, which is 3. And then I also believe I went over dividing by the highest power. That also works. So this one is just ratio because x and x are of the same power. So 2 over 1 is 2. And then same thing, x squared, same power, so it's 3. Ratio 2/3, right? Okay, so here are some harder ones that I circled. So we have the limit as x approaches infinity of 2x to the third plus 5 over 3x squared plus 1. So you can see that 3 is greater than 2, so the power is greater on the top than on the bottom. So for that one, you will so limit as x approaches infinity, 2x to the third plus 5 over 3x squared plus 1. Yes, so for this one, you can plug in a number, that would work, but also, well, okay. You could graph it. Well, yeah. You can graph it, but I don't know how to graph. So, if the highest power on the numerator is 1 above the highest power on the denominator, then you can sort of cancel that, right? Like x third, x squared would become x, which is positive, so then you'll be approaching infinity, positive infinity. I guess you could also say that 2 times infinity, like 2 times like a really big number, third plus 5 over 2 times a really big number squared plus 1, so you'll have, this one will be a lot bigger than this number, making it reach infinity. That was a bad explanation, but moving on, we can do f. The limit as x approaches infinity, 3x minus 2 over square root 2x squared plus 1. Okay, so for this one, we'll have to find the horizontal asymptote because it's approaching infinity. So we can see that the highest power, we would divide each term by the highest power. So we would think that it's x squared, but actually there's a square root, so it's just x. And then if it's x, then you can take the ratio, so 3 over square root of 2. But then if you want to do it the divide by the highest power, it would be 3x over x minus 2 over square root of 2x squared, oh, not squared there, plus 1. This would be over x squared, and this would also, oh, it is all in one, also be over x squared because it's still in the square root. So then these cancel. If there's a constant, it goes to 0, and then these will cancel, and alright, constant, so that will go to 0. So you'll end up with 3 and square root of 2, so that. And then that's the answer. This one, they just rationalized it, so you multiply the top and bottom by square root of 2 over square root of 2. So you can see that that becomes 3 square root 2 over 2. So now let's look at g. G is the same, but it's approaching negative infinity. So for that one, it approaches negative infinity because this one, yeah, its limit as x approaches negative infinity of the same function. So we can do the same thing. 3x minus 2, and then over the highest power, right? All over square root of 2x squared plus 1 over x squared, constant. So these two will cancel out, so you'll have 3 over square root of, these will cancel out too. But since it's a square root, it's plus or minus. And since we're approaching negative infinity, we'll use the minus, so it's negative 3 over square root 2. Yes, and that's the answer. And then h, this looks hard, but highest power is the same, right? So you take the ratio 2. And that's how you do that.